Okay, in this video, we're going to be creating another confidence interval, but this time instead of using statistics or using summary data, we're going to actually have a list of data to input into the calculator, and we will be referring back and forth to our recipe for success on how to approach a problem. So I make sure you have that available to yourself. So a professor at a large university believes that students take an average of 15 credit hours per term. So this is the belief, all right? A random sample of 24 students. We have a sample size of 24. In her class of 250 students reported the following number of credit hours they were taking. So we have this list of credit hours. And then it says find a 95% confidence interval for the number of credit hours taken by the students in the professor's class and interpret the interval. So basically, they're wanting us to create a 95% confidence interval based on this data. All right, so when I take a look at this, the very first thing the recipe says is define the parameter mu in context. Well, mu is going to be the average number of credit hours because that's what our interest is in. So let mu equal the true population mean number of credit hours taken by students for this professor. These are key words. Please do not get rid of this. Let mu equal the true population mean. That should be part of any time you're doing a confidence interval for means. To start with that. And then we're talking about credit hours. So there's the credit hours for this professor. The next thing it's going to do, our recipe tells us to do, is write the conditions. It should be random sample. The sample size needs to be less than 10% of the population, and we need to have a normal population, or n needs to be greater than or equal to 30. And if it's not, and data is given, we're gonna have to draw a box plot to show normality. All right, so here we go. First off, random sample, that was given, so that's taken care of. And she said up here that we took a random sample, so that was taken care of. We had a sample of size 24, and if we divided that by 0.10, that's 240. And the class was 250, so that's less than 10% of the population of 250 students. Please remember, that's recognizing that we're sampling without replacement, so things aren't truly independent, but we're basically saying it's close enough, as long as our sample size isn't too big. So basically random sample size isn't too big. And the next thing is normality. And so we need to check to see whether or not our box plot is normal. So here's what I do. I've input my data. I went to stat edit, and I input all that data into one column, and it all went into one column. And then we're going to need to go ahead and create a box plot. And I know it's been a while since we've done that. So you need to take a moment, input the data. Once you've done that, you're going to press the second button, second, followed by the stat plot. Make sure stat plot 1 is on and everything else is off. And I got stuff that's on that I don't want on. So I'm going to drop down to this and make sure this stat plot 2 is off. Go back to plot 1. And one other thing that I should do at this point is I'm going to go to y equals. Make sure there's nothing in there. Everything's cleared out. So that's good. So now I'll go back to second stat plot. Make sure that's on. So arrow over so it's on. And I'm going to drop down until I get to the box plot that shows outliers. Well, I'll put all my data in L1, so it's going to be second 1. And my frequency is going to be 1. And sometimes you get this crazy Y, in which case you're going to have to press out, back up, alpha 1. If you get it again, hit 1. You need to make sure that this says 1. And then you're going to press zoom 9. And there I have my box plot. And if I go to my trace feature, minimum of 12, oops, go to my trace feature, my lower bound's 12, Q1's at 15, 16.5, 19, and 21. I'm going to pause this for just a moment. Okay, so basically this is what I got. And when I look at this, this is pretty symmetric. All right, so I need to sketch that box plot out. And you can either use a scale or label all the important points. And so this is my minimum, this is Q1, this is my median, this is Q3, and there's my max value. And then make sure you always have your label, so credit hours taken. But it's not enough to just draw the box plot, you have to say something about it. In this case, the box plot is reasonably symmetric with no outliers. The distribution appears to be approximately normal. This key phrase, you need to stick with a phrase that's similar to that. There are going to be times that the box plot is pretty skewed, but it's not. So you'll say not excessively skewed, or still call it reasonably normal. I mean, reasonably symmetric. You're not going to call it normal. You'll say reasonably or approximately or somewhat or not excessively skewed. Make sure that it has no outliers. If it has an outlier, chances are you made a mistake in your data entry. So go back and put that back in there, because they're going to want you to draw, they're going to want you to make, to complete this problem. So you're going to need to do this and then sit there and go, you know what, it's good enough. The distribution appears to be approximately normal. By the way, again, key phrase, approximately, all right, or reasonably. We're not going to say it is normal, but we're going to proceed with it, okay? So we always have to say that it's approximately or somewhat or not excessively skewed or something like that, okay? So I've input all the data into the calculator, and I'm going to go back over to stat edit, which is where I have it. I'll press stat followed by calc, one variable statistics. My data list is an L1, so second one. I don't need the frequency on. And I end up finding out that I have a sample mean of 16.65. And this was a sample standard deviation. So our sample standard deviation is 2.222. This would have been the population, but we only took a sample. We took 24 students out of the 250. So we only have a sample, not the entire population of 250. So we'll write down SX, all right? So that tells me my standard, my sample mean is 16.65, and this is 2.22. Then I'm going to go ahead and write my formula out for my confidence interval. My formula is basically X bar plus or minus T star S divided by the square root of N, and I start plugging in what I know. Well, I know X bar was 16.625, so 16.625 plus or minus. I'm going to always leave a space for T star because I'm going to come back and have to fill that in later. We said our standard deviation in this case was 2.222 divided by the square root of, my sample size we said was 24. So I have this information. Now I need to go calculate T star. Well, we wanted to calculate a 95% confidence interval. So this is 0.95, because we're always going to be centered about our X bar. And remember, our X bar is our best estimate for the population mean. So this is our best estimate. And this is how much error, this is the margin of error. And alpha equals 1 minus 0.95. So our alpha equals 0.05. And that's just the area in the tail. Well, since we have two tails, this is going to be 0.025, which is half of 0.05. And this is the other 0.025. And we'll develop the topic of alpha later. And we're going to be looking for ultimately this lower bound and this upper bound, right? So that's what we're looking for when we do this, but we need to calculate our T star. And here's how you do that. You're going to go second vars, inverse T, and our area is going to be 1 minus 0.95. That's our confidence level. Close the parenthesis and divide by 2, because that's going to give you your area in the tails. And our degrees of freedom are going to be our sample size minus 1. So 24 minus 1. And we end up getting a T star value of 2.068. Now, technically, it gave us a negative, but as there's a negative 2.068 and a positive, and I want to keep it simple so that I don't lose negative signs. So this would be 2.0686. Make sure you write down your degrees of freedom, which I haven't done yet. My degrees of freedom are going to be 24 minus 1. Okay. All right. So now I've shown all my work, and this is great. So this will take care of us for work shown. And now I'm going to go ahead and run this. I'll go stat, arrow over to test, and I'm going to drop down to number 8, which happens to be a T interval. A lot of times your calculator is going to be on stats, and you're going to need to arrow over to data because we have a data list in the calculator, and our data list is in L1. Frequency is 1, and I need to make a 95% confidence level, so 0.95, and I press calculate, and that gives me my lower bound and my upper bound. So my lower bound is 15.686, and my upper bound is 17.564. 15.686 and 17.564, and basically that's this lower bound and that's that upper bound. So that's what we just found was the bounds for our between our confidence interval. All right, and then we need to write our conclusion. So let's go through this real quickly. So on this one, for points for our rubric, this part right here would probably be about worth 1 point, including the box plot. Our calculation part is going to be worth another point. So all the way to getting this, that'll be worth another point. And then we need to write our conclusion. So our conclusion is we are 95% confident, and remember this is a key word. We don't deviate from this, and by the way, it's on the template. We are 95% confident the true population mean. It says restate the definition. Our definition was credit hours. So true population mean number of credit hours taken by students for this professor lies within the interval 15.686 to 17.564. And that would take care of explaining the confidence interval. But it also says interpret the interval. When they say interpret it, they're looking for an interpretation, and we'll give this in just a moment. So this is the interpretation. And then we're also going to go a little bit farther, and we're going to interpret the confidence level. So we're going to interpret the confidence level, which says in repeated sampling, if I do this over and over again, we expect that this method will capture the true population mean number of credit hours taken by students 95% of the time. And again, this will probably get us another point. So then we have this last statement. And this is usually how they come up with the fourth point. And it'll be something like this. Does this sample indicate that the students are taking more credit hours than the professor believes? Well, what did the professor believe? The professor believes that they're taking 15 hours. Okay. And I look at my interval, and 15 is below the interval. It's not contained in the interval. So because our interval does not contain 15 and lies above that number, in other words, our interval is above that number, this sample indicates that the students are on average taking more than 15 credit hours. Notice I included the word on average. It's not the students are taking, the students are taking on average more than 15 credit hours. Because guess what? We have a group of students who are taking less than 15 hours. So you have to say on average, okay? And this part right here would get us typically the fourth point, and that's how you get 4 points for this question if this was on an AP exam. All right, thank you for watching.